A very good morning, good afternoon, good evening to all my dear friends and students. Welcome back to this DADM 2 lecture under the NPTEL MOOC series, which is the data analysis and decision making 2. And as you know, we are discussing the non-parametric methods like DA, HP, TOPSIS, Electra, MACBETH, all these methods. And this total course duration is for 12 weeks, which is for 30 hours. Each week we have 5 lectures, each being for half an hour. And after each week we have assignments. So, we are in the 4th week and we have already completed 2 classes in the 4th week, and we are going to the 18th lecture for this DADM 2, and my name is Raghunandan Sengupta from the IME department, IIT Kanpur in India. So, if you remember last class, which was the 17th lecture, we discussed about the formulation, simple formulation of DEA. We considered the output oriented model, we considered the input oriented model. I did not discuss the radial model, I will come to that later on when we discuss how the solution methodology should be done. I have only given the formulation, if you remember, in the first stage. Now, we will discuss a very simple technique where my utility analysis can be used in a very big way to find out the decision you are going to take. Now, this is basically known as the decision tree analysis. So, in the decision tree analysis, because all the concepts we have covered, the theoretical background is already done. So, I will immediately go into the problem solving. I will take 2 problems, solve it, and then obviously the assignments would be accordingly. So, hopefully I will be able to solve one problem in one day, which is in the 18th lecture, or if possible I will try to finish both this 18th lecture, I will try to utilize to solving both the problems. So, what are the key steps in decision tree analysis? So, they are, as noted down, is basically you have to identify the problem and the alternatives. So, what is the problem? Problem, is it related to finding out the best decision in terms of expected value, or is it basically the decision to find out the decision where the expected values are the same, but we want to find out the minimum variance, or is a decision where for all the minimums we try to find out the maximum of them, or is it that we want to find out the minimum of the decisions such that we make the minimum loss, and so on and so forth. So, obviously, it will depend what is the metric or the criteria based on which we are taking a decision. It can be trying to basically maximize the profit, it can be trying to minimize the profit, minimize the loss, my apologies. It can be, say for example, try to take a combination of them. Say for example, if I find out the ratio of the mean value with respect to the variance. So, what I am trying to do is that I am trying to take the per unit return with respect to the variance, where we can consider the variance as some sort of loss. Loss means some sort of money which is going out from your pocket. So, if we have the ratio of the expected value to the variance, we will basically rank them from the maximum value to the minimum value and take the one which gives us the best benefit with respect to the expected value to the variance. Other way can be, say for example, I try to find out the minimum of the ratio, where the ratio is now the ratio of the variance to the expected value, such that I rank them from the minimum to the maximum and take the one which is minimum with respect to the criteria which we have set for ourselves. Now, obviously, the criteria which we are talking about can depend on other constraints. So, other constraints, if we remember for the DA, to give an example, for DA we have different constraints, like say for example, the ratio of output to input is less than equal to 1, the ratio of input to output is greater than equal to 1, depending on what type of oriented model you are looking at, either it is input oriented model or output oriented model. Similarly, you will have different type of constraints coming up in the scenario of decision trees, but our main focus would be on 2 very simple problems where we want to basically find out the expected value and rank them accordingly. So, next point which is mentioned under point 1 is the alternative. So, for basically for any decision you have different alternatives. So, alternatives can be, say for example, you want to buy a house. So, a house can be, you can buy in consider the city of Delhi, you can buy in Hauz Khas, you can buy in JK1 complex or JK2 complex, you can buy your house in Pitampura, whichever area you want to buy. Now, the main criteria when you want to buy a house would be, alternatives would be, it will have different type of criteria based on which you want to find out the alternative. Say for example, you want to buy a house which is on the cost wise is the least. You will also want to buy the house on which the safety aspect is the maximum. You want to buy a house where from the point of view of mode of transportation is nearest to the metro station or nearest to the bus stop or nearest to the auto stop. It can be, say for example, you want to buy a house where it is nearest to the school where your kids are studying, or it can be a house where it is nearest to the market or the bazaar where you want to buy your things. So, there would be different criteria. So, obviously, it would may mean that trying to maximize the criterias based on the different criteria which I mentioned, like the market, the school, the safety, the price, the location, considering the transportation facilities, all these things may not be possible at the same time. So, obviously, you have to rank them accordingly and find out which is the best alternative, such that you find out the best combinations of the criteria which will give you the best alternative suiting your budget in all respect. Budget does not mean only money, it can be all the points which I had mentioned. Or say for example, you want to buy a car. So, these examples for the car or the house would not be considered here, I will just consider a simple decision trees of, say for example, on a marketing firm and basically based on the oil exploration example. So, other example which I was talking about can be the car. Say for example, you want to buy a car where the car color is important for you, the price of the car is important for you, the safety of the car is important for you, what is the maintenance cost of the car is important for you, maybe say for example, what is the boot space, the luggage space of the car is important for you, or it may be how many number of passengers it carries is important for you, what is the resale value is important for you. So, all these things when you consider, they would be many conflicting ones, conflicting criteria, but your main decision is to consider that alternative where the criteria are combined in such a way that you get the best benefit. What is best for you may not be best for me, but you have to basically analyze from the point of view of the decision maker. Now, in the second step, you basically delineate the decision tree, that means you find out the alternatives, find out the routes. Routes means the way they can go, and basically draw the diagram in such a way that following any path it will give you one of the paths you can take to reach that alternative. So, whether that is good or bad, that you have to make a decision later on, but it will basically give you at one go the different type of paths you can follow to reach the decision from the starting stage, which will consider the source, to the sink stage, which basically is the alternatives decision which you are going to make. The third point would be basically to specify the probabilities of the outcomes, because considering in decision trees there are alternatives which will have probabilities. So, probabilities can be, say for example, if there are 3 cars you want to buy, the probability may be with respect to the probability of buying, considering the cost factor, may be that brand X you want to buy with probability of 70%, brand B you want to buy with probability of 20%, and brand C you want to buy with probability 10%. That would be based on the price, but say for example, on the aspect of safety, may be that alternative C or C brand may give you the highest this level of safety. So, obviously, the probabilities of safeties would definitely would be reversed, where C would be higher than B, then which will be higher than A. So, obviously, these probabilities on cost, on color, on safety and all these things which I mentioned may not go in hand, that means they would be basically at different directions. By the word direction means that one may be high in one case, that means the alternatives car A, B, C with respect to the cost, A would be best, while with respect to safety, as I mentioned, C would be the best. So, you have to basically make a compromise giving some quantitative values. You specify the alternatives and you also specify the monetary values. The reason why I am saying the monetary values, because it is much easier for us to understand that how monetary values or monetary figures can be utilized in order to understand that how the decision can be taken, such that you can rank the alternatives from the best to the worst, or from the worst to the best, depending on what your criteria is. In the fourth stage, obviously, so we have delineated the decision tree, draw it, specify the probability. So, what is important is the probabilities and the monetary outcomes, and the next stage would be to evaluate the various decision and alternatives which are there. So, say for example, for car A, B, C which I mentioned, you will basically take all the paths considering all the alternatives and basically arrive at the decision such that it will give you the best benefit. The word best I am using specific to one person who is taking the decision. So, in this case, you should identify the problem and the alternatives, that is important. You should delineate the decision tree, which is important, that means draw it. Then you should specify the probability on the monitored outcomes which are respect to that each and every decisions you are going to take, and you evaluate the various decision alternatives such that you find out the best combination which will give you the best benefit. Remember the decision tree also called a decision fork tree. So, they would be forks, that means there would be different arrows moving out from one decision, and these forks would basically decision points will be denoted by the capital D, while the alternative actions are available from where alternative actions are available for experimentations and different actions are possible at that point, while the chance point where the chance is taken would be denoted by the symbol capital C. Now, D would be denoted by a square, while C would be denoted by a circle, and obviously there can be different forks coming out from D and C accordingly, and we will mark the probabilities accordingly. Probabilities is basically the third point which I mentioned, remember it. While the chance points, let me continue reading it, called the forks denoted by C are the points where the outcomes are dependent on a chance process, and the likely outcomes of these points would be considered in totality such that we arrive at the best decision. So, as I said, we will consider examples only. So, first let us read one example which is a simple one, then we will basically make it a little bit more, I will not use the word complicated, more involved, in the sense that a lot of information is going to be given, you have to find out the best alternatives such that it will give you the best decision. So, let us read the problem. The scientists at Spectrum have come up with an electric moped, because all the concept which we will use are already considered, is very simple case of utility theory application. The scientists at Spectrum have come up with an electric moped. The firm is ready for pilot production and test marketing. This will cost 20 million rupees. And this monetary unit which I am mentioning, rupees, dollars, it is immaterial here, but I am going to consider the values as given. So, and obviously one question would be coming up time and again, that how we are going to utilize the concept of utility. I will mention that as we proceed. So, this will cost 20 millions and take a time period of 6 months, which is a half a year. Management believes that there is 70% chance that the pilot production and test marketing will be successful. So, I have already read, the firm is ready for the pilot production and test marketing, and that will take 20 million rupees. Let me continue reading it. In case of success, Spectrum, the company, can build a plant which will cost 150 million rupees. The plant will generate an annual cash flow of rupees 30 million continuously for 20 years if the demand is high, because they have already test marketed it and done a pilot production. So, it will be 30 million each year for the coming 20 years if demand is high, for which the probability is 60%. If you read it, I will come to that later on. And if the demand is low, the annual inflow of cash would be 20 million, and it is also, we are considering that the time period is 20 years. So, 30 million 20 years, 20 million 20 years, but obviously there would be many very simplistic assumptions which I will slowly relax and tell you the background how you can solve the problem. As I was mentioning, high demand has a probability of 60%, while the probability of low demand is 40%. You have to basically help the scientists at Spectrum to arrive using the decision tree analysis to arrive at the best alternative. So, again I repeat the main important points. It will do a pilot production and test marketing which will cost 20 million. I am not using the units of rupees, dollars, whatever, I am just mentioning the values, 20 millions, time period is 6 months. The management believes there is 70% chance the production and test market will be successful, obviously 30% is not successful. In case of success, the company can build a plant costing 150 million, and if the demand is high, it will get 30 million for each year for the coming 20 years, and or else if the demand is low, it will get 20 millions each year for the coming 20 years. Now, the high demand probability is 60% and the low demand probability is 40%. So, these are the main points, and I am sure if you have listened to it carefully, you would have noted down the important facts which are important. Now, I will immediately go into the diagram. So, this may be a little bit, I will try to reduce it. This is the diagram. So, this is the optimum size I can show it to you. Now consider the diagram and I will come to the values which are stated. So, I will go explaining the diagram from my left to the right, but when I solve the problem it will be from the right to the left. Why? I will come to that later. So, you have the green vertical lines are the stages of evaluation. So, there is stage 1, stage 2, stage 3 for evaluation. If you remember, we said that we will denote the decisions fork from the square, which will be denoted by D, and the chance one would be denoted by C, which is a circle. So, it has been denoted likewise. So, for the decision stage, when you are taking the decision, it will denote it from the left as D1. So, this is the suffix D1. I will now highlight it, so it is easier for us to understand. So, this is D1. So, in D1 when you go, there are two paths. Path 1 is if you remember, it would basically do a test marketing for which it will invest 20 millions. So, this 20 millions which you are seeing, which is red in color, red means that is the money is going out from my pocket or Spectrum company's pocket. So, this D11 would be 20 millions negative, and D12 which is denoted here, I will do nothing, that means I would not start the business, I will just not want to carry on forward, because it is possible that if I do and invest 20 millions and 20 millions also out from my pocket, it may prove that in the long run the overall value of the project is negative, such that it would have been better if I have done nothing for this whole project. Now, in the second stage, once you have invested 20 millions to do the pilot plant and the marketing. Now, as I mentioned in the problem, there was 70 and 30% chance that of probability that you should basically continue with building the main plant and continue with the business, and 30% chance was that you do nothing. So, obviously, from the point of C12 where you do nothing, where you stop, you do and you do not take a decision, the probability is given as 30%, which I have already mentioned. And if I take the upper route, which means I take the C11 route. So, this the initial part was 30% was the C12 route, that means I am going down, and the decision would have been D3. These are just nomenclatures of the suffix of D1, D2, D3, D4 are just mentioned from the left hand side to the right hand side. So, but obviously, we have a rule that as we follow it from left hand side to the right hand side, we either give the numbering from the top to the bottom or from the and obviously from the left to the right. So, C11 has a probability of 70%, which I have already mentioned, and C12 has a probability of 30%, and once 30% that the test marketing does not yield anything, I will do nothing and stop this production, which is given as D31, because D3 is the decision point which is shown by the square. Now, if the 70% is true, then obviously there can be two alternatives. Number of alternatives, one would be I build a plant and the cost, if you remember, is 150 million, and again it is red in color because I am investing from my pocket. I means the Spectrum company, and the other alternative means that the probability is high, that means 70% is true, but I do nothing, that means I just waste that money and do not continue the business, because it may be possible that if the demand is, if I continue to do a production, it may be possible that in the long run the overall value for continuing the business may be negative. So, in this case we do nothing, stop. Similarly, in D31 we stop and do nothing. Stop and do nothing are the same thing. Now, if we have invested 150 million, it may be possible, and as I had mentioned that there is 60%. So, obviously, when we come to that point of C2, so this circle is C2, let me write it down. So, it will be easier for us to. So, this will be C1, this will be C2. Now, when we consider the high demand and the low demand, the high demand and the low demands are given by probabilities of 60% and 40%, which I have already mentioned, and the income which is happening for high demand and low demand is respectively as this: 30 million for each year for the coming 20 years, 20 million for each year for the coming 20 years. So, now you may ask that why it is 20 years for both the case. Yes, that is true, that if it is high demand, it may be possible that 30 millions is being is the income we are getting each year for maybe for the coming 20 years, and for the low demand it may be possible that we get 20 millions per year for the coming, say for example 15 years, but I am just taking a very simplistic assumption. So, with this decision we need to basically find out the best alternative. Now, there is a concept which is known in optimization as the stagecoach problem. So, in stagecoach problem a person is going from one east coast to the west coast or west coast to the east coast, whichever way you are analyzing. So, it starts from, say for example, from area of New Jersey or in the east coast and then goes to California, and it is following different routes. Stagecoach means this horse drawn carriages. Now, for each routes there would be cost for travel per unit, there would be, say for example, safety issues, they can be waiting time, so on and so forth. So, all these things, positive and negative inputs are taken in order to arrive at a decision. So, obviously, there are different forks or different routes the stagecoach can take to start from the source, which is the east coast, and reach the sink, which is the west coast. Now, whenever trying to analyze this problem, best would be that you start from the end stage and work backwards to find out that if the alternative you had taken was, say for example, either path 1 or path 2 or path 3. So, which paths you would have taken in order to reach path 1, path 2, path 3. That means, you are going one stage at a time, going backwards, and then slowly trying to find out the best combination of the paths such that you are able to eliminate all the other paths which would not give you the same benefit or the same maximum benefit. So, when I solve the problem, this will become clear to you. So, we will start from basically from the right, and that is the sink, and proceed on to the left and basically reach the source in order to find out the best alternative. So, I will pause for 1 minute, have a look. We are starting from D1, 20 million we are investing, and then there is a probability of good business, bad business, 70%, 30%, 30% we do not do, 70% we do. That means, again we invest 150 million to build the actual plant, high demand, low demand being 60% and when what wait 1 minute, 60% and 40%, amount of money coming is 30 million for 20 years and per year 30 million, and another case being 20 millions per year for 20 years. And do nothing means basically we do not either go for the project or stop the project, is that means we just stop at that stage. So, you have to basically balance all the alternatives with amongst each other, so arrive at the best decision which is possible. Now, let us go one by one. So, if you go from the right, so what we will do is that we will try to find out the expected value of C2 and then work backwards. So, let us find out the expected value of C2. So, what is the expected value of C2? Now, at C2, which is the rightmost circle which is there are probability 60%, 40%. So, 60% would be multiplied by the net present value of the 30 million which you are getting each year for the coming 20 years, plus the 40% of the net present value of the 20 million which you are getting each year for the coming 20 years. So, this is how we do the calculation. This is the probability. So, this 30 which you are doing, we are multiplying by the so called net present value factors for the first year, second year, third year till the 20th year. That means, if I had a value of P, I am doing it in red color. Now means consider on 1st of January 2019, the interest rate was R, and I am basically investing that money for 1 year. So, at the end of the year 2019, that means on 31st December 2019 or 1st January 2020, the total amount of money which I will have in my pocket would be P into 1 plus R to the power 1. This power 1 goes to the value of 1 plus R. Say for example, if you, so this would be the value after the first year. Say for example, you find out the value after the second year. So, let me use a different color, so it will be easy. P plus, and I am not taking out the money in between. This is the value which is after the second year. If this is the value, this is the value after the third year, this is a plus 1 plus. Similarly, the value which I get after the 4th year, that means once I invest I continue that money. Now see where this calculation used. Now it is saying that I receive 30 millions after each year. That means after the first year, if I have a value of 30 million, so when I do this calculation, so this first year value is 30, 1 plus R is, which is what is given. I need to find out P. So P is given by 30 by 1 plus R to the power 1, and this is the value which I have here. So just look at it. Now let us go into the second calculation for the second year. So let me use the different color. So first let me erase it. This is, I am going to do the calculation for the second year. So this goes, so this was basically first year. Now I do the calculation for the second year. The second year value is also after the second year, which is now 31st December of 2020 or 1st January 2021. This is 30, P value, P is a variable, so obviously it will be utilized. So when I use P, it becomes this. So this value which I have is exactly the value which I had here. So if I come to the third year, so have a look. I'm just one thing. So you may be thinking, why am I using the same value of R, interest rate? Well, that is a simplistic assumption, interest rate change. So obviously technically the R which I am using for the first year, second year, third year, fourth year can change. So let me do the third part with the same value of R and come to the change values which I can do. So the third year value is again, third year now becomes 31st December 2021 or 1st January 2022 is P 1 plus R cube. So P is equal to 30 divided by 1 plus R. This value is coming here, there would be a third year, so it is not there, so I am coming. So obviously the concept which you are talking about R being different, if that is true, be R1, this would be R2, the R1, R2 are different, this would be R3 suffix and this would be R4, and you will continue doing the problems accordingly. So with this I will end the third lecture in the fourth week, which is 18th lecture, and continue discussing more of the decision tree in the next two lectures, and definitely wrap it up in all the details as necessary. Have a nice day and thank you very much.